Okay, so in practice exercise 17b, we're asked to calculate the concentration of oxalate ion, which is our 2 minus ion. And going back, I can see in my Ka1 and Ka2, my oxalate ion, C2O4 2 minus, is formed in my Ka2 reaction. So I'm going to need to use this equation to figure out my oxalate molarity. And I see in So here I'm going to start by writing the reaction, my Ka2 reaction, because I know I'm going to be forming my 2 minus ion. So my Ka2, I have to start with my HC2O4 minus, aqueous, react with H2O liquid. It's a weak acid, so I have equilibrium arrows. I'm forming C2O4 2 minus, aqueous, plus hydronium, aqueous, and my Ka2 expression is going to equal C2O4 2 minus times hydronium, H3O plus, divided by HC2O4 minus. And so now I want to go ahead and set up my standard icebox template, ICEQ. I know my initial molarities I must get from my previous table. So we cross out water. I know underneath my equilibrium arrows, my X value is going to change. And now I need to think about where to get my initial values. Well, my initial molarities of these reactants and products come from my icebox 1. So in icebox 1, I see I have both HC2O4 minus, which is equal to X, which was 0.016, and hydronium, which is also equal to X. And so I can see X from before was 0.0158. I'm going to go ahead and use just 2 sig figs carrying forward, so 0.016 molarity. So now we're going to take that value and put into our initial row for HC2O4 minus and H3O plus. So initially, again, and I got those values from my icebox 1, the values of X, 0.016 molar. So now I'm going to go ahead and write those down for my initial, so 0.016 molar for HC2O4 minus and 0.016 molar for hydronium. Nothing is mentioned about C2O4 2 minus, so that's going to be 0. My change is minus X for the reactants, plus X for the products. And then I go ahead and add up the columns, so 0.016 molar minus X, X, and 0.016 molar plus X. So now we need to stop and think, how do I solve for X? Well, I know I'm going to use my numerical value of Ka2, which was given on the previous slide, so 6.4 times 10 to the negative 5th. So let's write that down. 6.4 times 10 to the negative 5th is my Ka2 value. Which equals, from my icebox, X times 0.016 plus X divided by 0.016 minus X. And now I can see that my Ka value is quite small. So again, small is typically 10 to the negative 3rd or smaller. We'll always go back and check. And I can see that my X is my oxalate. So my 0.016 plus X is my hydronium, and the 0.016 minus X is my HC2O4 minus. So that's how I set up that expression. Again, pointing out that 10 to the negative fifth is small. So our shortcut, we're going to assume that X is smaller than the number it's being subtracted from or added to. So in comparison to 0.016. So we're going to make both of those X's 0. Only the X that is being added or subtracted from another number turns to 0. And now we end up with really simple math. So we can write 6.4 times 10 to the negative fifth equals X times 0.016 divided by 0.016. And now I can see my 0.016 upstairs and downstairs, those do indeed cancel. So I end up with 6.4 times 10 to the negative fifth equals X. And now we need to think, what are we actually solving for? Well, first let's go ahead and check, make sure, is X really small? That's what we're going by our 5% rule. So I take my value of X, 6.4 times 10 to the negative fifth, divide it by the number it was being either added or subtracted to. It's the same in this case, 0.016 times 100. So into my calculator, 6.4 e negative 5 divided by 0.016 times 100. Enter, and I end up with 0.4%. So that is definitely smaller than 5%, so our shortcut works. We do not need to go back and use the quadratic formula. So now we need to go back and think, what am I solving for? So I'm trying to get my C2O4 2- molarity, or my oxalate ion molarity. And looking at my icebox, I see that my oxalate molarity, right there, it at equilibrium is indeed X. And so I can say my oxalate molarity is 6.4 times 10 to the negative fifth molar. And that would be our final answer.